Hi, this is Chris from Discover eLearning and welcome to episode 12 of our Storyline Magic series here on the Discover eLearning YouTube channel. Before we get into today's video, I'd like to share the exciting news that our second Advanced eLearning Developer Series online course will soon be ready to launch on our website. This is going to be a brilliant course for all articulate storyline professionals, as we'll be exploring a highly creative development technique that turns the humble scrolling panel object into an X-ray window onto your slide. Not only will we go through the JavaScript programming that can make this happen in fine detail, but the course will also focus on several practical applications for the technique to help you generate some interesting ideas of your own, making it an ideal way to develop new creative technical skills that you can put into practice right away. Be sure to visit our website to take advantage of the last few pre-registration days remaining to get a 20% discount when the course launches. Now back to the subject of today's episode, which is going to be all about emphasis animations. As you may have seen this announcement by David Anderson that there will be a selection of new animations coming to Articulate Storyline in the near future. The details surrounding when exactly this is going to happen are still clearly very much on a need-to-know basis, hopefully not on the day you're watching this video at least. But still, you might not be aware that there are already a number of emphasis animation techniques that we can create with our shapes, images and groups in Articulate Storyline, all with the help of GSAP and a bit of JavaScript coding magic. The benefit of controlling your animation with GSAP is that you get access to a wide range of motion settings to fine-tune your animation, from various easing options and bounce controls that help you simulate effects like gravity. It'll be interesting to see just how many of these settings might eventually make their way into the software. For today's video, I'm going to show you how you can use GSAP to create this pulsing animation, which helps to draw your learner's attention to areas of the slide that require it. Then, as an added bonus, I'll show you how we can use the scale and rotation effects in GSAP to create this lift, flip and drop 3D card effect. Let's take a look at our starting project, which you can download from our website using the link in the video description below. On the base layer, we have a plain background and border with a trigger that opens the starting layer with our front card design. We'll just be working with one card during this tutorial to keep things simple, but you can repeat the technique shown for as many additional objects as you wish for your own project. In my file, there is also a back of card layer and also another front of card layer, which is a duplicate of the start layer to infinitely switch between the back and front of the card when the user clicks. Each layer, as you can see, is set to not hide one another when opened. We'll instead be doing that with triggers at the end of each layer's timeline as we move from seeing the front and back. The character design on the front of the card is a looping animated GIF, which I've generated from a free Lottie file. Using a GIF looks better when it comes to you watching this tutorial, but we absolutely can, if we wish to, use a JSON Lottie file within our project instead of a GIF file. More on that later on. Final things to take notice of are the data accessibility values, which I've set for every group on the layers, as well as the star that we'll be creating our pulse animation for. Let's get started with that right now. We'll create a new layer to act as our timeline for the pulse animation specifically. This will be 4 seconds long, and I will create a trigger to loop back to the start of the timeline when it ends, so it could play indefinitely. Now at the 0.01 second mark, so practically at the very next frame when the timeline begins from the very start, I will create an execute JavaScript trigger in order to scale the size of the star up from its starting width and height. On the first line, we will type var zoom1 equals document dot query selector all, with a capital S and a capital A, and then in parentheses and single quotes we will open and close square brackets and type data -acc -text equals, and then in double quotation marks, gold star. End that line with a semicolon. We are using a query selector all method here, as you may wish to have multiple stars pulsing on the slide. and this technique is an effective way of applying the effect to any other object in the scene with the data accessibility text value of gold star. Now on the next line, type GSAP.to and in open and close parentheses, zoom 1, comma, and in curly brackets, we'll set some parameters for our transition. Starting with duration, colon 2 for 2 seconds, scale, colon 1.6, which will scale the image up 60% greater than its current scale, X% with a capital P, colon -0, and another comma, and Y% with a capital P, colon -0, which will scale the object up from its originating position. Let's add another comma and type ease, colon, and in double quotes, cubic.inout, which is my option of easing style for the animation. And then finally, comma, force 3D with a capital D, colon, false, which is a recommended step for an animation of this style. Make sure to end that line with a semicolon. Click OK on the JavaScript editor window here, and let's now duplicate the trigger we have just created and have this version execute at 2 seconds on the timeline, i.e. straight after the previous animation has finished. In the JavaScript code editor, the only option I want to change is the scale value to put this back to 1, or 100% of original width and height. Let's go onto the base layer now and add a trigger to show the pulse timeline layer when the timeline starts on the base layer. Let's now publish the project to our desktop in order to view the result. That has created a simple but effectively eye-catching animation for our slide to guide our user towards interacting with the card on screen. Now let's build our 3D flip card effect, starting with the initial start layer. The first trigger I'm going to use is a change state of trigger in order to change our start object to hidden once the user has interacted with the card. I will also create a trigger to show the back layer. Now I will create an execute JavaScript trigger in order to create my flip animation over 90 degrees for 1 second. Start by typing const card front with a capital F equals document.querySelector with a capital S, and then in open parentheses and single quotes, we'll open and close square brackets and type data -acc -text equals and card1 in double quotes. End that line with a semicolon. To target our card group object, then type GSAP.to and then open and close parentheses and type card front with that capital F, comma, and then in open and close curly brackets, the options duration, colon 1 for 1 second, comma, rotation Y with a capital Y, colon 90 for 90 degrees rotation on the Y axis, comma, and then ease, colon, and in double quotes, power1.in. Let's hit OK on this and click into the card back layer, where we will want the card animation to initially start in the 90-degree position, ready to be turned clockwise to be flat facing when the start layer's 1 second animation is over. To do this, I will type const card back with a capital B equals document.querySelector with a capital S, and in parentheses and single quotes, open and close square brackets, and type data hyphen ACC hyphen text equals, and in double quotes, card 1 back. End that line with a semicolon. And then on the next line, GSAP.set, and in parentheses, card back with that capital B, comma, and in curly brackets, rotation Y with a capital Y, colon, and negative 90. End that line with a semicolon. We then want to rotate the card at the 1 second mark, which is when the initial flip has taken place on the start layer. So I will create a new execute JavaScript trigger to fire at the 1 second mark on this timeline. Let's type const card back 2 equals document.query selector with a capital S, and in open parentheses and single quotes, open and close square brackets, and type data hyphen ACC hyphen text equals, and in double quotes, card 1 back. End that line with a semicolon. And then on the next line, gsap.to, open and close parentheses, and type card back 2 with that capital B, comma, and then in curly brackets, we'll type duration colon 1, comma, rotation Y with a capital Y, colon 0, comma, ease, colon, and in double quotes, power1 dot out. End that line with a semicolon. To finish things up with this, I'm going to create a no-click transparent mask shape here to ensure the card can't be clicked again until all animations have completed. Let's publish this and take a look at the results so far. Looking good. So let's continue now with adding the same effects, but this time going back to the front of the card using the second front layer we have created here. I'll start by adding a show layer flip card front trigger when the back of the card is clicked on this layer. From the back layer, I will take a copy of the JavaScript code we are using at the start and 1 second into the timeline. We'll need to make just a few edits to both of these, starting with the query selector method to instead target the card1 front group on this layer. Let's also change the variable assignment name here and here. Then we just repeat the same steps for the next execute JavaScript trigger. I will now take a copy of the execute JavaScript trigger that runs when the front card is clicked so that I can apply the same effect to the back of card layer. Make the adjustments as required to target the card group on the back of card layer. Let's copy this trigger to the other front of card layer and perform the same steps. I'll also create my click trigger on the second front of card layer to take us back to the back of card layer, thus creating our navigation loop between the two layers. Let's now hide the back layer when the timeline ends on our front of card layer. And hide the front layer on the back of card layer. Remember that our reset initial status setting is still active on all of these layers, so this is important to create our loop. Let's see the result of the changes we've just made in our browser. Okay, now what I'm going to do is add a hover effect to each card group, which will slightly grow the card to give the impression that it's being lifted off the table. On the start layer, we'll create a new execute JavaScript trigger when the timeline starts on the layer. Begin this code block with the classic var player equals get player line. Next, we'll assign the card group to a variable, which we'll call myCard1. Now we'll write our GSAP code in order to play our animation when the mouse is hovered over the group. So let's create a function that uses the mouse over event listener in order to make this action happen. Type myCard1 with a capital C, dot add event listener with a capital E and L, and then in open close parentheses and double quotes, the words mouse over without a space between them, comma, function, and then another open close parentheses and open close curly brackets. But we only want this to happen if we are certain that the card animation is not currently playing. So to do this, we can use a new project variable, which I'm going to set up now to be called isCardFlipping, and set the initial value of this to no. Then I will create a new trigger when the card has been clicked to change that new variable to the value yes. And the same for the other two card animations. Then on these layers, I'll create another trigger to change the value back to no once the timeline ends, which is when we know all animations will be complete. Let's go back into our JavaScript editor window now and put this new variable into action. Start with an if statement to check if the player variable isCardFlipping is not equal to yes. And if the card isn't flipping, we will use GSAP.to, open and close parentheses, myCard1 with a capital C, comma, and in curly brackets, scale, colon, 1.1. End that line with a semicolon. Let's duplicate that event listener function now, and this time plan for what happens when the mouse out event occurs. In this situation, we want the scale to return back to 1 or 100% of original size. Take a copy of the two event listener functions we have just built, and let's copy these now into the timeline starts execute JavaScript triggers we have in place on the other layers. Make sure to also add in the classic var player equals get player line to the top of your script window for both layers. Now we also want the cards to remain in their larger state when the animations are playing on each layer. So let's open the execute JavaScript code window for when the card group is clicked and add the line gsap.set, open and close parentheses, card front with a capital F, comma, and in curly brackets, scale, colon, 1.1. End that line with a semicolon. On both the back and front of card flipping layers, we will also want to add the scale 1.1 value to our existing gsap.set function when the timeline starts on these layers. Then at the 2-second mark on both the front and back animation layers, we need a new GSAP script to scale the card size back down to 1 when the flip animations have completed. So let's create a new execute JavaScript trigger at the 2-second mark and type const card back shrink with a capital B and a capital S equals document.querySelector with a capital S and open close parentheses and single quotes and then open close square brackets and type data hyphen acc hyphen text equals and in double quotes card 1 back. End that line with a semicolon. Then on the next line we will type gsap.to open and close parentheses card back shrink with that capital B and S comma, and then in curly brackets we'll type duration colon 1 comma scale colon 1.0, returning the scale to original size. End that line with a semicolon. Let's copy this trigger and paste onto the front card layer and edit the code as required with the data ACC text value of the front card group object. Let's now see the finished result of our flip animation for our card using GSAP. We'll finish up our project now with a few additional tips. When the timeline starts on the original base layer, I'm going to add the following execute JavaScript code. window.onResize equals function, open close parentheses, and in open close curly brackets, location dot reload, open close parentheses, and a semicolon. This is simply a way to manage a situation where the user may resize their browser window in order for object position and scale coordinates to be recalculated for our GSAP animation tweens. It's a simple method to use for smaller projects like this, but if reloading is a problem, it can be managed instead through GSAP using an event listener connected to the browser resize action. We can come back to this in a future Storyline Magic Series episode. I'll now create a next step layer in order to show how with a simple trigger and a variable used on the layer, we could potentially cause something else to happen, like a next button appearing on the slide once all cards have been clicked. To do that, we could create a trigger to change the true-false variable when the user clicks on the card. And then on the base layer, set up our show layer triggers at the moment each variable changes, checking that all card click variables have also changed to true. Okay, last but not least, let's take a look at how we can swap our animated GIF file for a LottieFile, which is beneficial for the performance gains that can be achieved, particularly with larger projects using many GIFs altogether. To add a LottieFile to a slide in Articulate Storyline, we need a web object which we can draw onto the slide like so. Then we need to get the object URL from the LottieFile website, which can be found when adding a file to your dashboard by clicking into the Handoff and Embed menu. Here, make sure the asset link format is set as Lottie.json and take a copy of the OEmbed link here to paste into Storyline. If you publish the slide, you will see the web object transform into your LottieFile once loaded. Be aware there may be some lag experienced, so you might want to consider ways to compensate for this by giving time for your web objects to load on the slide. Now we can take our web object and replace the GIF version by copying and pasting in its place within the card group. just publish the project in order to check the size and positioning and adjust as required until you are happy. This has been one of our biggest Storyline Magic Series tutorials to date, so congratulations for working through this project if you have been following along in Storyline. And I hope the techniques you have seen are possible using GSAP provide you with a ton of scope for exciting new ideas you want to try creating yourself. We'll be sharing even more tutorials like this in the near future on the Discover eLearning YouTube channel. So if you'd like to support what we do, then please do give this video a like and hit the subscribe button for our channel to hear the moment we have a new video ready to watch. And for more great learning opportunities for Articulate Storyline 360 developers, you will find our Advanced eLearning Developer Series courses over on our website. These cover lots of advanced areas for e-learning development professionals, such as our very popular OpenAI ChatGPT API and Articulate Storyline 360 integration tutorial course. Thanks for joining me, take care, and I'll see you again very soon.